Okay, so we already did this first example of partitioning a directed line segment in class today. But just to reiterate, so I can talk my way through it, which is better than the answer key. Step 1 is right here. You see that the 1:2, 1 to 2, that changes into 1/3, so first over total. Step 2 is to create your triangle and count boxes to figure out your x number and your y number. In this case, x was 9 and y was -12. You then take 9 and -12, you multiply by that 1/3, and you end up with 3 -4. And your last step is to add back in your first point, which in this case was -5, 2, and you get -2, -2. Now, you can tell you're right, because if you go to -2, -2, you are right on the line, on the segment, which means you're right. Okay, second one was completing the square. Now this one's all mixed up. This is another reason why I like to draw that fence, because we need to take the 8x and move it to this side. We need to add the 6y and move it to this side, and 39 can actually stay there. So what we really have is x squared minus 8x plus y squared plus 6y, and on this side all we have is 39. So it's more like that because of where the equal sign was. But so now that we have it all organized with the x's and y's on the left and the constant number on the right, our x's, the way I wrote them, are already together. So x squared minus 8x, leave some space. Y squared plus 6y, leave some space. Half of 8 is 4. Square that. 16. Half of 6 is 3. Square it. 9. But remember, whatever you add here, you have to add there as well. So now when I factor this, I have x minus 4 all squared, because the square root of that sign, square root of that, x minus 4 all squared. And the same thing here, y plus 3 all squared. And on this side I have 39, 16, and 9, which adds up to 64. So that means the center is +4, -3, with a radius of the square root of 64, which is 8. Now, it's actually a separate question, but this one down here is the same type of thing. All right, I'll help you get it organized left and right. We have x squared. I'm going to put the 6x with it. So I just took this and chunked it together. Might as well leave some space while I'm at it. Then I have y squared. And notice the 8y is over here right now on the wrong side of the equation, but when I add it back, it's going to be positive. 8y, leave some space, equals 56, which was already on the right side. So this I can tell, in fact all of these, the way the font is showing, these were old Regents questions. So it was a little bit mixed up as far as the terms, but now that we have it in this form, we should be okay. So what I want you to do is half of 6 is 3, so squared is 9. Half of 8 is 4, squared is 16. So we write those in, and then we have to make sure to add the 9 and the 16 over here as well. Then you go to your perfect square trinomials, and you take care of this. So it would be x minus 3 all squared. And then you take care of this side. So it would be y plus 4 all squared. And then you add 56, 9, and 16, which happens to be 81. So now I have 81 over here. And then you have the center, and you have the radius. You figure that out from this and this. Okay. On the back, remember to pause this anytime. I know I'm not leaving breaks between, but that doesn't mean you can't stop the video. So I talked about this in class. This is partitioning, but there's no graph paper anywhere. Now you could go find graph paper or reuse an old piece, or if it's on the Regents, you can always use the piece they give you at the end of the book. But one thing I was showing you in class was, if you can just figure out how far it is from -1 up to 8, which is 9, right? And then you can figure out how far it is from -3 up to 9, which is a jump of 12. You've taken care of the triangle already. Because that's really what the triangle is for, is to figure out how far x is and how far y is. So if you had drawn your triangle, that's where these would have come from, right here. But we can also do that just from saying, how far is it from here to here? How far is it from here to here? So now that we have 9 and 12, we normally would have done this first, but 1 to 2 is 1/3, right? So now I'm going to take 1/3 of 9 and 1/3 of 12, which is 3, 4. And then I'm going to add back my first point, which was -1, -3. And where does that land us? All right. Another completing the square problem. Let's chunk our x's. This one's in a nice form. Nothing's really mixed up here. Leave some space. Here's the y's. Leave some space. And the 144 was even on the correct side. So half of 8 is 4, squared is 16. Half of 12 is 6, squared is 36. So if I added 16 and 36 to that side, I got to add 16 and 36 to this side. Then you're going to make your perfect square trinomials. And I have x plus 4, y minus 6, and you have 144 plus 16 plus 36, which I think is 196. But based on what you have in here, what's your answer over here? For this last one, I can tell if you look down here, it was a Regents multiple choice question. It gave us 4 choices that were uncompleted squares, but it gave us a graph. So before we even get started, let's just see if we can figure out the regular equation to this circle. So the center looks like it's at 5, 2, and the radius appears to be 4 boxes long, right? So we have a center at 5, 2, so opposite of 5, opposite of 2, and if the radius is 4, I have 4 squared there, which is really 16. Okay? So we normally wouldn't do it this way, but they're testing our skills to see if we know where it came from. If we expanded this, right, x minus 5 squared is really that. Y minus 2 squared is really that. Let's see if this can help us at all. Okay, so let's double distribute this. So it's x squared minus 5x, which is minus 10x, positive 25, because negative 5 times negative 5. Over here we have y squared minus 2y is minus 4y. Negative 2 times negative 2 is positive 4. So let's combine some stuff here. I think we're going to be able to figure this out sooner than later. We have 16 over here now, but when I take away 25 and take away 4, let's see what that leaves us with. 16 minus 25 minus 20 or minus 4. 16 minus 25 minus 4 is negative 13. So on this side of the equation, I'm going to have a negative 13. That's cool because 2 of those have negative 13. So we know it's not these two. Now what else do I have left now? X squared minus 10x plus y squared minus 4y. There it is right there. So that's not something you would need to do. You always want to go the other way, but they're testing your skills there to see if you know the basics of where completing the square comes from. We sort of covered that the first day, but I think pretty intense for a multiple choice 2-point question. But it is what it is. Quiz tomorrow on partitioning and completing the square.